Welcome to March's Leetcode challenge. Today's problem is flip binary tree to match preorder traversal. You are given the root of a binary tree with n nodes, where each node is uniquely assigned a value from 1 to n. You are also given a sequence of n values, voyage, which is the desired preorder traversal of the binary tree. Preorder traversal starts at the node and then goes left-right. Any node in the binary tree can be flipped by swapping its left and right subtrees. So for example, at node 1, we can flip 2 and 3 to be 3 and 2 if we'd like. See if we can do that to match our path and voyage. Now we want to return a list of all the values of flipped nodes, and if we can't find one, then we'll have to return a list of -1. So we already know that we're going to be doing a depth first search or breadth first search, depending on whichever one you find more intuitive. I'm going to go with depth first search. This problem is very difficult, to tell the truth, and the reason for that is we need to figure out if we can actually do this preorder traversal. At every node, we're going to have to be going down a single path, but it's like we have to figure out if we want to go right, left, or left, right, or if that's not even possible. So inside of some sort of global variable, I'm going to make a list that keeps track of all the nodes that we've traversed. If we found that we couldn't find one inside our condition, I'm going to put a none inside of that list. And that way we can track that and say, hey, you know, in our path we couldn't find a value to match our path, so that's going to mean we have to return a -1. We'll also have to keep track of the direction that we can go. If we can go left, right, then we don't need to change the direction. But if we have to go right, left, I'm going to put in some sort of variable that says go right, left instead, and keep track of that inside of our output. So the very first thing we want to do is create some self variables. I'm going to call this path, and I'm going to call this current. This one's going to be a list of all the nodes that we had to swap, and this one's just going to be an index number of where we are currently in our voyage. So now we need our depth first search, and we're going to pass in the node. The very first thing, if not node, or let's say our self.cur length of voyage. If self.cur equals the length of voyage, that means our algorithm's over, so we can just return. Okay, the second thing we want to check is to see if this node is equal to the voyage inside of what we are in current. Because if it's not, then that also means we need to end our algorithm here. So let's see. If voyage self.cur does not equal node.value, then again we'll return, but we'll also add to our self.path a none, and this we'll keep track of later, because if this was the case, we have to say we couldn't find one, so we'll have to return -1. Now otherwise, what we'll do is increase our current pointer by 1, because we have found that this node matches the one side of voyage. And it will also keep track of the direction that we want to go. So I'll call this direction, and this will start with just left to right, which would be 1. So the first thing is, do we need to swap? Well, if we need to swap, we can say check our node if we have a node.left and node.left.value does not equal wherever we are in our voyage, self.cur. If this is the case, then we know we need to swap. So in our path, we'll say append this node.value, and we will switch our direction to equal -1. And I'll show you why we did this here. The reason I did this is now we need to continue down our preorder traversal, right? But which order do we go? Do we go left to right or right to left? And we'll say for child in, let's make a list, node.left and node.right. If we found that we have to go the other way, or we have to at least try the other way, then we'll just, this direction thing here, we'll make sure to take care of that, and we just call our depth first search again with the node, or the child. Now we need to call our depth first search at the root. And really, it really depends here. We either return the self.path, all the lists of node values that we've swapped, or if there's a none in the self.path, we'll return a list of -1. So let's see if this works. I believe this should return -1. It does, and go ahead and submit that. And there we go, accepted. So this actually ends up becoming O of n because we do traverse every node, but we're only going to do it one time, depending on which path we can take. And it'll stop early if we find that we haven't been able to find one, and we'll return -1 if none is inside this path. So I'd love to say that I came up with a solution on my own. I did not. Although my approach was very similar, it was taking a little bit too long for me to get all the edge cases, so I had to look it up. But my approach would have been similar. I think I would have eventually got it. I wish I had more time to go into like a deep dive here, because this actually is a more difficult problem than it kind of initially seems. So I hope this helps. Thanks for watching my channel. Remember, do not trust me. I know nothing.